Hello everyone, I am Praneeth. Welcome back to the channel. Today, let's see about AWS Lambda. Before going to that, we'll get a short definition about what is Lambda. AWS Lambda is a serverless computing service that runs code in response to events and automatically manages the underlying compute resources and pay only for the compute time that you consume. So let's deep dive into the key features of AWS Lambda. I'm opening the Lambda from AWS. Let's create a function. While creating the function, we'll see what are its key features. So we have three features, three types here. Author from scratch, user blueprint, container image. We have a short description of each and every option over here. It's self-explanatory. So let's give the function name. So coming to the first key feature of AWS Lambda Functions. It has multiple language support. Like if you see here, we have the runtime. So runtime is nothing but the languages that it supports. So it supports for Node.js, Python, and Ruby. So we have different versions of it as well here. So I'm currently choosing the Python 3.11 architecture. So based on the instruction set, so we can choose between x86 and ARM64. And so the next is integrated security. Lambda integrates with AWS Identity and Access Management, in short IAM, to control access to the resource and ensure secure execution of the code. If you look into this, so we have here the default role of execution. So we have three options over here. So the one thing is if you are creating your first Lambda function, either you can go with this, it will provide the basic Lambda permissions as it says, and the or else if you have created and it's a new function, you can choose between existing role and create a new role from AWS policy templates. I'm clicking on use an existing role. I have already created a role over here. It's called Lambda Auto Deploy. So if I go to IAM in the roles, you could see Lambda Auto Deploy. So it has a set of permissions, what this role should do. So it has these policies attached to this role. So based on this, if again to execute a Lambda function, the basic role we need to have is AWS Lambda execute. Without this role, without this policy, we can't, Lambda cannot execute the function itself. So this is how we can control the Lambda, like what can it access, how should it execute. So using IAM, we can control the Lambda execution policies. So to know more about roles IAM, I have already created a video on it. I'll leave the I'll leave the link in the cards and in the I button as well. You can refer from that. So let's move to the demo. Now in the advanced settings, these advanced settings are self-explanatory. So if you want, we can enable this and play with it around. So for this demo, just I'm moving with the create function. The first and the next feature is event-driven execution. Lambda functions can be triggered by a variety of events from different AWS services like Amazon S3, DynamoDB, SNS, CloudWatch, and more, and many more. So we can see that from here. So we have an option called Add Trigger. If you click it, so we can select the source from a wide variety of options available here. So we have Alexa, API gateway, so whatnot. So we many AWS services are available here. you can yeah go through, and it has partner event sources as well. So you can go through the list. For now, yeah, we're not adding any trigger. I'm going to the function again, going back to the function. So let's have a simple lambda code over here. So it has a simple code. So if we want to test it right away, so can click on test, and we need to create a name for it. See, so we got just like a response status code, hello from lambda, which is available over here. So the next key feature is scalability. Lambda automatically scales the function by running code in response to each trigger. There is no need to manage any servers or infrastructure. For instance, if when a function is invoked, AWS Lambda launches an instance of that function to process the event. If multiple event occurs simultaneously, Lambda scales out by running multiple instances of the function in parallel to the process of the incoming requests. So yeah, if we have a trigger, if a SNS receive, for example, if the trigger is SNS, if SNS is triggered the a lambda, so it will run. If multiple comes, it will automatically trigger the function and it will run in parallel. That's what it meant. And the cost control, the next key feature is payment is only for the compute time the function consumes. And billing is calculated based on the number of requests and the time your code executes in increment of 1 millisecond. Yeah. The next key feature is flexible resource allocation. You can allocate memory to your function from 128 megabytes to 1240, sorry, 10,240 megabytes. And Lambda allocates the proportional CPU power and other resources. So we can say this in the configuration. Yeah, but you can, yeah, think it's somewhere in the general configuration we could see here. So the memory, if we click on edit, will get its configuration settings like between what memory you want, 128 and 10,240 megabytes. We can choose this between, and the ephemeral storage what we want. And the timeout plays a major role because sometimes we could see, I mean, we are waiting for a response. If we are sending a response, if we are waiting on that, sometimes it takes more than 3 seconds. Then we can arrange the timeout here. Maybe we can extend it to 1 minute, 2 minutes based on your calling returning function, the time it takes or consumes to compute that logic and returns a response. So we can adjust the time, like the timeout value as well here. And moving to the next key feature is environment variables. So you can configure environment variables for your Lambda function, make it easy to manage configuration settings and secrets. So in the configuration itself, we have the environment variable section. So yeah, let's add a couple variables. So for example, let's take, I mean, my secret is it number. For now, its value is 10, and I'm another adding another secret num2. It is 5. So let's save it. If, again, we have another option, encryption configuration, if you want. So yeah, we can have some encryption. So here it says enable helpers for encryption in transit. So yeah, if you want to have some encryption through this, so we can apply. For now, I'm going without the encryption. I'm clicking on save. So I have two environment variables. So let's modify the code according to that. I'm going with the simple basic code for now. So in Python, the environment variables are get accessed using the OS input. So I'm importing OS. So num1 equal to OS dot get env of the name over the secret or the configuration. We can check. We need to get it from environment variable. So I'm getting those num2. Now some let's num1 num2. So instead of this, let's print the sum. So yeah, here we did not declare any variables or for num1 and num2. We are directly getting from environment variables. So if we change the code, the one thing we need to do for a lambda function, we need to deploy it. So post the deploying, we can test the code. I'm clicking on test now. So yeah, we got 105. It's taking it as a string. That's why it is concatenating. So if you want to do the real mathematical sum, then we can type convert to int, and I'm gonna deploy it. If you test once more, you'll get 50. Yeah. So that's it with having configuring the environment variables for the lambda function. And one more thing is we have lambda layers. Layers are a way to manage and share code and data across multiple lambda functions. You can include libraries, custom runtimes, and other dependencies. For example, by default, Azure. So Lambda, out of the box, Lambda doesn't have the request module. So for just I say import requests, and let's for now comment this code. Response equal to request dot get of example dot com. So the response, so just I'll go with the status code. Oh, response dot status code. All deploy. I'm testing it. So we could see we got an error like import module error, no module name request. So if in your code you encountered a situation where any third party dependencies needs to be part of your lambda code, then what we can do is, so we need to add those dependencies through the layers. So if we click, that there are two ways. If you scroll down, we have this option, or else from here itself, you can click it. It will navigate us to the bottom, and you can click on add a layer. So before adding a layer, what we need to do is we need to, the starting itself in the layer section, we need to create a layer. So since I have already imported the request letter, the the thing how to zip the layer is, so in your system you'll do that pip install requests, right? So grab the you do pip install request and zip the directory, and that's it. So on the create, if you click on the create layer, it will ask where we need to upload from, either zip file edition or local instance or from Amazon S3. I have already created the layer, so I'll provide the steps for how to zip the layer. So in the description. So now let's move to the function. Now I'll add a layer, request layer. I'll go with the custom layers because it's our own. dependency, right? I mean, we need this dependency which is not available from AWS layers. So I'm clicking on request layer, version. Yeah, one version, I have only 7. I'm clicking on it and I'll click on add. So by adding it, what I can directly now test it. Now it says, I mean, we got the 200 status points. Earlier we got import module error. Now the layer has been added for the request. It finds it and it successfully runs our code. This is how we can add the external dependencies if required for your Lambda function to execute. The next key feature is versioning and aliases. So this is important. So the versioning and aliases in AWS Lambda are powerful features that helps manage deployments, rollbacks, and overall lifecycle of your Lambda functions. AWS Lambda allows us to create multiple versions of Lambda functions. Each version is immutable and has unique on means Amazon resource name that identifies it. So first, let's see how to create a version. Then let's go for its benefits and let's see the aliases later. So yeah, so the one thing we need to keep we need to be aware of is, so if we create a version, AWS Lambda captures the code and its configuration settings. The configuration settings, maybe the memory size, environment variables. So, I mean, at that point of time, what we have the code, it will capture those things. So, here directly we can go to the versions and I'll click publish a new version description. Two numbers. Publish. I'm publishing it. So, a specific on is being created based on the version name here. So this is what I mean on will be created. So we have its environment variables and the configuration as well. General configuration we could see we have the same configuration. And again we can go to the code. So for example, we are make assume that we are making a new change. Oh, okay. We are having okay. Here we have the example.com. Let's say we'll write an amazon.com. Yeah. Yeah. Okay. Oh, we are in the version 1. I'm again going back to the code and I'll change it from example to, oh, okay, I said the description as sum of 1 and 2. Yeah, no problem. Let's create a version 2 and name it properly. So now what I'll do is, now I'll change it example to Amazon. But I'll deploy it, I'll not create a version of it. So if we test it now, we got 503 error. Fine. So if you want to create a version of it out of it, we can create a version and publish a new version. Mm, we can say testing Amazon or I'm publishing it. Now we'll get a version 2. We'll have separate arms for it. So then we can go to the Lambda function. So if we have created two versions, so if we want to go to those versions, we can click on it. And if you want to, if you go to the version 1, now since version 1 saves this all configuration, if you click on test, we'll get the uh, 200 response code. I mean, the result as 200 because it saves that URL. If you see the, yeah, if you see the code over here in the Lambda function, it says, so, I mean, what does we have discussed? So, when creating a version, Lambda keeps the record of the code, environment variables, and the configuration. So, it is a separate version. Like, we can think it as of a version control system. So, this is how version works. This is how it works in the versions for AWS Lambda. And so we have two versions. It's fine. Yeah. Now, if we go to the second version, since it's a second version, it has updated code. If we test it, we'll get the same. We'll get the 503. We can think it is of a GitHub or any other source control management tool. So this is how we can maintain versions of our Lambda functions. Lambda brought us this functionality, this feature as well. So if we go to the benefits of the version, what we can is first is immutability. Each version is immutable, meaning it cannot be changed once created. We have seen it. We have two versions. Version 1 we have example.com, version 2 we have amazon.com. So once it is created, so we can't change the code. What I meant is, so if we go to the versions, if I click on version 1, if I try to change something over here in the code, I cannot able to do that. See, I'm clicking on backspace. It is not allowing me to modify something. So it is completely immutable. And the consistency, the next is consistency. Deploying specific versions ensure that same code and configuration are used across different environments. If we have different environments, so we can have the different configurations for different environments, and we can use its respective versions, so we can have the consistency. And the testing, it would be easy. I mean, since we have the versions, staging, I mean, we can test in staging environment, dev environment staging, and the pre-prod, if you have, I mean, all your pre-production environments, and we can promote them to the production and roll back. And if assume if few versions or a new version of Lambda is creating some issues, we can roll back to the previous version without having to redeploy the code, because we can just map it to assume version 2 is having give me 503. I want to revert back to the function, I mean version 1. I can directly use this on. I mean, we can have the logic between the changing, and we can do the steps. So the thus rollback also made easy using this versioning and aliases. Now let's move to the aliases. So again, I'm going to remove lambda function. We have seen versions. Now let's move to the aliases. Now let's comment this. So aliases are pointers to specific version of a lambda function. They provide an additional layer of abstraction and helps manage deployments by allowing you to reference the function versions with a friendly names. Okay. Yeah. Now let's see aliases in action. So the one thing with version is we have one, two, three. We have this numbering version, numbering fashion. So again, these versions sometimes we can't remember the numbers also. So aliases are like calling with like we can't remember each and every guy phone number at whom we met. We save those numbers on relating to the person's name for identification. So this is the same way. We can't keep track of the versions. That's why we have the aliases. So once alias, we can refer to that specific version. So I'll name it as the prod, and description. This alias is referring to prod version. So now the latest again, it takes the latest is nothing but the code. I mean, if we make changes to the code, we'll see the deploy option, right? That would be the latest of code, or else we did if you not make if you want to choose between the versions, we can choose, or if you want the latest code changes to be deployed right away, so we can go for the latest, but it is wise to choose between the versions. So prod, I'm choosing the version 2, and we have again weighted aliases. So yeah, you can explore on it. So we can clicking on save, and I'll create one more alias just for the I'll use the version 1. Create alias def this carries the version 1. I'm clicking on save. So yeah, so this is similar to the version concept, but we'll have the user friendly names and aliases. Again, coming to here, aliases also, we have this on, so we can directly have this to directly point this, give this on to your trigger, or so it will only call the prod each time. So we, since we can configure it, we can configure it to the which version we need to map every time. So the name would be static. Again, we won't change this prod unless any naming conventions. Apart from this, we can have the trigger and add the destination if you want. So trigger is a triggering point. Destination is like we can have the emails, or we can get the notifications based on its status, either it's success or failure. So if failed, what should we do? We can have those things later. Configured. So this, destination is nothing but the endpoint. We can generate destination would be the emailing process to know the status, how the lambda went it went good or it failed. So to go get those notifications, we'll add the destinations usually. So these how these aliases, this is how aliases work. So we can give this on so if we'll get it from a trigger, we'll give this on to the trigger, then it will only hit on the prod. So we can change the versions, or if new version 3 comes, version 3 is the latest, and it has prod configuration. So we can directly change the version instead of changing the name or version when each time create. And for example, what I'm trying to convey is we'll create multiple versions. So soon the version 4 or 5 will come. So we can't, every time we can't go and change the trigger. Instead, in the trigger itself, if we give the prod as a function on with the on value for this lambda function, if we give the prod, so what it does is it will always refer to the prod. Here we can change the versions. So in that cases, it will avoid us the overhead. Each time changing the production version values. That's what I'm trying to say. And one more interesting what I felt is in the lambdas is, so I think, yeah, we, 1 second, I can show you here. We can directly create a public URL. This is called the function URL. So if here we can go, or else we can go to the aliases. So for prod, I'm thinking I need to expose this as an URL. I can create a function URL. So for now, I'm going with none without any authentication. And clicking on save. So I'll get this function URL. So with this URL, we can directly use it in Postman or web. So we'll get that response right away, executing the Lambda function. So this is how these function URLs work. This is also, yeah, one thing I like about the Lambda. If we see the benefits of the aliases, the first thing is friendly name, and second is simplified updates. Like to deploy a new version, you can simply update the alias to point the new version, like what we discussed. If version 4 is our latest and it's a prod version, so you can directly go and change in the aliases, like version 4 is a prod version, instead of changing it from the triggers. And canary deployments. Aliases support traffic shifting, allows you to direct a percentage of incoming traffic to a newer version. This enables canary deployments. So yeah, canary deployments are like only the new functionality or new Lambda function will be available to only couple of your I mean smaller portion of your large customer base. First, if they receive if their request or success, if their feedback is good, then only it will extend its a newer version completely. It will wait 100% newer version. If canary deployment is having some issues, then it will revert back to the old version. This is called the canary deployment. So through aliases, it has that functionality of the canary deployments. So that's what yeah, that's what about the canary deployment. And the safer rollbacks, as in the versions we could see that if any issue detected with the newer version during a canary deployment, we can easily roll back to the pointing the aliases to the old version. Like in your aliases, you have shows that in our case itself, this is the prod URL, right? Yeah, we see it's 503. So what I'll do is I'll go to the configurations. I'm getting the 503, and I'll point it to the version one, and I'll click on save. And if I refresh this URL, I'll get 200. You see how quickly I can revert back or roll back to the existing working version if any surprises or getting noticed during the production deployments. This is it, guys, about Lambda. If you like the video, do like, share, and subscribe, and comment your thoughts on this video. See you in the next video. Bye.